All right, time to go teach. Hello and welcome to this episode of Tutors, where we are continuing our introductory unit. Today we are looking at how we visualize our data. So let's get started. First up, targets of the day. We are going to describe the purposes of graphs, or why we use graphs, because graphs are how we visualize data. Next, we are going to go over different types of graphs used in science. And lastly, we're going to compare and contrast those different types of graphs, how they're used, when it's appropriate to use each type of graph. So let's get started. First off, what is the purpose of our graphs? Well, it's really to visually represent the data. A lot of times, our data is quantitative. That means it is numerical. And numbers, they sometimes are really hard to understand when you just look at a data table. It's really hard to see what's actually taking place here. And so we are going to want to use a visual representation of this data table. And that will also allow us to tell a story. So that way we can explain what has been happening throughout our experiment. We can describe what effects our variables have had, if they have had any effect at all, based upon how we can visually show our data. And that's the purpose of a graph. And that's also why it's really important to use the appropriate graphs. Choosing the appropriate graph will allow us to show the audience what we have found through our experiment. So let's look at some graphs. Well, they are three main types. So you have line graphs, bar graphs, and pie charts. And we're going to go through each of these in order. So first, line graphs. How do they work out? Well, line graphs are going to be used for continuous data. In other words, they're going to be used for data that is linked together. So in this case, it could be the height of a plant over time. And so we are just showing how tall this plant grew each and every day. Through this, we can see the rate of growth for this specific plant. So it visually illustrates changes in our data. And one of the really common uses for a line graph is going to be to graph our data against time. And time would always be on the x-axis in this case. When you set up a line graph, it works out. You have your y-axis, you have your x-axis, and those are going to have very specific things upon them. To understand this, I use this acronym, DRY mix. DRY stands for the dependent variable, which is the responding variable. It goes on the y-axis. Mix is for the x-axis. It stands for the manipulated variable, which is also the independent variable. That is going to go on the x-axis. So every single time that you set up a line graph, you are going to set up the dependent variable upon the y-axis and the independent variable on the x-axis. Another acronym to think about is LAST. So we're going to use these letters L-A-S-T. So we have to label our data. We have to label our axes. We have to set up an appropriate scale along the axes. And we have to give our graph a title. And that allows us to have an appropriate setup for our line graph. Dry, mix, and last. That gives us all the information we need to set up an appropriate line graph. There is a difference between a line graph and a scatter plot. A line graph has all of the data points connected. A scatter plot is instead going to show a trend line going through the data points, showing us the overall trend that is taking place for our data points. So a line graph actually is going to have all of the points connected, whereas a scatter plot, which is a type of line graph, is going to have a trend line. Both are useful in science, and it just depends on what it is that you're trying to show. If you're trying to show how something has grown over time, or how a population has gone up and gone down and gone up and gone down, that would be where you're going to connect each of the data points. If, though, you're trying to show what has been happening over the course of time and just to show the general trend, then you would use a trend line. It just depends on what story it is that you're trying to tell to your audience. Next, we have a bar graph. And bar graphs, that's for categorical data. So data that is in specific groups. And those groups are each going to be represented using a bar. Those different groups are then going to be able to be compared with each other based upon the bar graph. And this can be plotted either in this way, vertically, or it could also be plotted horizontally. It doesn't matter which way it's plotted. That's really the preference of the person who is making or constructing that specific graph. And when you are constructing a graph of this type, well, we would have to use a different acronym. When you're setting up a bar graph, you would still use the dependent variable, which is the responding variable, goes on the y-axis. So we still use the word dry and use the exact same words. But the x-axis no longer is set up in the same way. Remember, it now has those categories, or it has these batches. The groups that you have constructed, they go on the x-axis. So each of those different groups are going to be on the x-axis. The y-axis is going to have the dependent variable. And remember to label your axes, to set the appropriate scale, and then to put a title upon your graph. A pie chart is a little bit different, where instead of looking at these different categories next to each other in bars, we're now going to actually visualize the values as a piece of a whole, or as basically a percentage. If you are looking at the length of time for different stages and development for an organism, that could be represented as a percentage of the organism's life, and you could use a pie chart. So that is the pie chart, and it is constructed by the different percentages taking up that specific amount of the pie. In summary, graphs, they are a visual representation of our data. They allow us to have a nicer view of our data set, which a lot of times is very hard to understand when you're only looking at numbers. It's sometimes really hard to see what the numbers are telling us without having a nice visual representation, which a graph gives us. And each type of graph has a specific purpose. If it's continuous data, we would want to use a line graph. If it is going to be categorical data, then we're going to use a bar graph. And if it is a percentage of a whole, we are going to use a pie chart. Remember that if we happen to have a y-axis, then that's where the dependent variable is going to go. But we don't always have a y-axis because sometimes you have a pie chart and they don't have y-axes. But for both the line graph and for the bar graph, you're going to use the y-axis as where your dependent variable goes. And constructing and analyzing graphs, they are crucial to understanding our data. They're crucial to science because they help us understand a little bit more about the world. And that is what science is all about. And on that note, be awesome, stay awesome.